Hello everyone, welcome to this video, and today we're going to think about how can we think about creating a stack-up and choosing a stack-up, and also creating an impedance profile based on this stack-up. And essentially everything kind of depends on the fabricator you're trying to use, or also if you have your own custom own defined stack-up, then you also have to take care of finding the characteristic impedance for your trace of your differential pair and also for your single pair. Now, a single inlet, my bad. Now, I intensively use GLC PCB, so I will be using this throughout this video. I think that so far they're doing a good job. Everything seems pretty much good to me. So let's see what we can do. So first we have to go to this design, and now we can go to the layer stack manager. And once we go there, you'll see a very basic pre-layout has been opened up, right? Now, this doesn't really tell you everything that you need to know because it's pretty vague. You have to define your own dielectric, DF, and whatever you want, but still, it works. And you can also choose your via plating thickness. These things will help you in case of you trying to simulate the board inside of the Altium Designer, which I necessarily don't do. I mostly use either ADS or either HFSS to do that, but you can also model your surface roughness, and you can do modify Hammerstead. It's a pretty common one. GLC-PCB doesn't really include the surface roughness model, I believe, but I think you can find SR and RF in one of the viewer questions. If a customer asks a question, I'll just put the link on the video if I can find it again. But that's not part of the discussion. Part of the discussion is that they will give you this predefined layout, and you may don't want to have it. You may want to add some new one, and you may want to insert a signal layer, or you may want to insert either a plane or core or prepreg, right? But how can we decide that what kind of stackup we need, and how should we move forward with that? What I will do is I'm just gonna go to the GLC PCB impedance calculator, and once I'm inside of the window, now I will be thinking about, all right, how many layers I can afford. Literally I can afford. If you're really trying to fabricate more than 6 layer board, the expense can go up. So I will just go with 4 layer, cheaper. Now think about, all right, what is my PCB thickness? How fat I want my PCB to be in? If it's a little bit more fat, it has more stronger, right? I mean, if the thickness is more, high, it's more stronger, definitely for sure. It may need some, more layers, because the problem with the big thickness PCB is that sometimes you have your reference signal, which is a ground, could be a little bit far. But if you have a PCB thickness of around like 1.2, you can probably, like even 1.2, whatever it is, you can probably sandwich all of your layers within really tightly, and that way you can get a much better reference to your ground. But everything depends on how you calculating your impedance. But just to know that depending on the capacitor or capacitance, your impedance is gonna be like high or low. So this is something to take care of in your mind. And the inner orange, that's basically the copper they put on inside, and this is the outer orange, which is the copper they'll put out outside. They don't really include the solder marks around here, but you can definitely include. Do you want a solder marks to be defined or not? By the way, if you go to their capabilities here, they do talk about like what they mean by finished outer layer copper, and you can see that finished outer layer is basically the copper on the outside, and there's the inner layer ones, as you can see here. So they're pretty good with that. They do also talk about some, I believe, the solder marks somewhere along. They does talk about solder marks intensively, but here you go, the solder marks probably here. So they tell you that the solder marks in thickness is 10 micrometer, and then the dielectric constant is 3.8. By the way, they just added this information recently, I believe, because I never really found this information before. So which is good. It's a good thing. Good thing for the user, for the customers, right? Now, once I'm done with that, I'm just gonna say, or what will be my impedance? Am I designing for 50 ohms, or then is single-ended non-coplanar is fine. If you're having a guarded signal, say like you have ground everywhere, like kind of giving you a shield, then you may want to have a coplanar. And if you don't really care about solder marks, then you can choose that if you want to, but I always do care about solder marks, so I will just skip it. Now I also want to see what is the impedance for the differential pair. So I'm gonna say differential non-coplanar, and excuse me, And sorry about it. And now I'm gonna just do or specify the spacing. I'll just say 10 mil. That's fine. Now I can do calculate, and that will tell me all the information that I need. By the way, there's a catch. This is just the calculated trace weight and trace spacing, just because for this stack up, which is 3313A. You can also change this one for different stack up based on what you need, but be mindful that they may charge you a little bit more depending on the stack up. So I sometimes use this one if I need a really big thick, you know, a bit wide trace width, and I do change them. But for now, I believe we should just do this. And this is very simple. Looks like it just have a one copper layer. It does have a pre-preg of 3313 RC53, and then they have again the same one. Then they insert the copper layer, which is your, maybe it could be a ground or whatever you want to. Then again your core is here, and then copper again, pre-preg, and then copper. They do define the constant of this pre-preg, I believe somewhere in the capabilities around there. Maybe you can find it. I was reading into it one day, and I did found there some of the dielectric constants of their pre-preg stuff, but unfortunately I can really see it within my eyes at this moment. But you can definitely, here you go. Yeah, there you go. So they will define some of the dielectric constant around. So if you're trying to simulate that, or if you're trying to use it for something else, you can definitely do that. All right, cool. So I'm not gonna do any more calculation. I'm just gonna go further and go to the Altium soon. But before I do so, I want to make sure I do have this number as I want it. All right, cool. So in the Altium, now the Altium, two ways you can basically import that. The first way is the manual way, which is basically take all of this stack of details and just dump it to Altium. It's gonna be too much work. And I don't know if you guys have all the time to do that, but thankfully there's a guy, JLC PCB. There's a person who created this repo, which includes all of the stack of our GLC PCB, which is really cool, and really shout out to this person. I don't know how to spell the name, but it's B Saverland, maybe, I guess. But shout out to him. He created this repo that has almost, I think all the preset template you do need for your board, and of the way it reads is 4-layer, 1.2 millimeter outer. So 1.2 millimeter thickness, outer 1 ounce, inner 2 ounce, right? And the second number. So for our case, this is a 3313A. So what we're gonna do is we're gonna go to Altium, we're gonna go to File, we're gonna go to Load a second from File, and from here we can just go and basically choose our stack up. I can go to my downloads, and I can go to GLC PCB here. There's one. I can go to the Altium stack up, and now I have to find out, alright, where is the stack up that has 4-layer, 1.6 thickness, outer of 1 ounce, inner of 0.5 ounce. So it should be around this section. So outer of 1 ounce, inner 0.5 ounce, 3313A, and this is the one we're looking for. So once you do that, it's gonna fill out the whole, the stack up thing. Now, next thing you want to do is you want to go to the impedance profile and make sure that the dielectric looks the same as you want it. Make sure everything looks good. But then you can go to the impedance profile, and here you can create add impedance. It's inside of the Altium. Altium also has its own calculator that will calculate the impedance for you. So the Altium is telling me that, brother, if you really want to have the 50 ohm, just make sure the width is 14.581. But GLC PCB, maybe he's not in the agreement. He's maybe a little bit off. But I always use the GLC PCB because I think they are the fabricator, so I should probably be using the one the fabricator is telling me, which is now giving me 51.94 ohms, almost close to 50, but not really. But as I said, it's the GLC PCB is my fabricator, so I want to make sure my fabricator is the one that I'm looking for, and I'm trying to design my board around the fabricator. And so far I got good results in my board too, so I'm very, very happy with that. I think using GLC PCB as your impedance calculator as your calculation probably fine. But let's go. Let's create a 50 ohms. Now we're gonna add so that I can create 100 ohm. So let's go to properties, say go differential here, and then let's add 100 ohm. Once you add the 100 ohm, now you can change that to spacing as, I'm just only changing the top layer. I don't really care about the middle layer right now. It's a video demonstration, right? I'm gonna copy this thing and I'm gonna go back here and change the width to what I just copied. Now it's giving me 107 ohms, which is a really big number, but as I said, you may need to tweak some of the value here to make it close as much as possible, but I always follow the GLC PCB. It's just what I've been doing so far. Alright, once you do this thing, you can get rid of it and make sure you save that. And now you can go to design and you can go to rules, because we need to make sure we reflect this thing in our design rule. So now differential pair, if I go to differential pair section, now I can just click on the use impedance profile and make sure you only apply these things to a specific match or layer that you think there's a differential pair. Otherwise, I mean, you'll be kind of messing up with your design. I will talk about it more, like, polarity parities and rules in the future videos, but just know that this thing exists. So the same thing can also use your impedance profile, but make sure again, change layer, nats, and whatever you need to do to make sure you reflect these changes or rules to your specific desires. Alright, I think this is enough for this video. I probably went above what I really hoped for, but thanks for watching. Hopefully to see you in the next video.